Hello everyone, welcome back. So let us start. Today we are going to start with next topic, that is classical crypto system. Yeah, in the classification of crypto systems, we had seen this classical crypto system. We'll discuss some simple crypto system popularly used in the pre-computer era. That's why it is called classical, because we are going to see pre-computer era crypto systems. That's why yeah. So one thing, uh, the plain text I am going to write it in the small letters, and then cipher text will be written in capital, say A, B, C, D, something like this. It will be, and your plain text I'll be writing with small, and I am excluding the space and any comma and all. Uh, this can be done if you take the space as not as suppose I am taking only A to Z, so there are only 26 letter, and the notation which I am using, see A, B, C to Z. So A I am writing 0 0, B I am writing 0 1, 0 2, and this guy Z is 0, sorry, 25. So there are total 26 uh, alphabets. If you want to include space, then you can put comma, that will be 26, exclamation mark, that is 27. So how it depends on your ciphertext. If you want to put space, and then you can increase your modulus, but here we are, for simplicity, we are just going to consider only the alphabets from A to Z. Yeah, so let us start one by one. The first thing we'll be looking as block cipher. So in the definition, we had already told that in block cipher, the key and the encryption algorithm is applied to the block of data at once instead of applying on each single alphabet. In block cipher, the key and the encryption algorithm is applied to the block of data at once instead instead of applying on each applying on each single bit, single, you can say alphabet or bit individually. That means we are going to divide our plain text into a block, the block of length 5. So we are going to consider 5 characters only. So there are two type of block cipher which we are having. One is substitution cipher and another is transposition cipher. One is substitution and one is transposition. And this substitution cipher is further divided as first is shift cipher, Let me just quickly just define what is substitution cipher, or will draw, or will just give you what are the different type. It has shift cipher, affine cipher, Hill cipher, Vigenere cipher, Hill cipher, I think one more was there. Yeah, auto key cipher. There was one more. Auto key cipher. In this class, we are going to cover all this thing or substitution cipher. In the next class, we will be doing transposition cipher. So, as per its name, in this cipher, the alphabets or characters are substituted by another alphabet. And so, I'll just start with the alphabets or characters are substituted by another alphabets or character that may not look like your plain text or characters. The substituted alphabet may or may not belong to the given plain text block, as I told you. So during the encryption, one character can be either replaced by a unique character or by more than one character. That means a single character, if it is uh, replaced by only one character in the encryption, then it is called mono alphabetic cipher, and otherwise it is called poly alphabetic cipher. That is, if one character is replaced by a unique character, is called the cipher is called mono alphabetic cipher. Mono means single. Okay, if one character is replaced by more than one character, the cipher is called polyalphabetic. Cipher. Okay, so let us see what are the different types. See, in all the five cipher I have given, these three people are even actually these two. One more I can put substitution cipher, that's okay. So this is monoalphabetic, these are polyalphabetic. This is mono. So let us see first monoalphabetic ciphers. The first one is shift cipher. What happens in shift cipher actually? Here my plain text space, cipher text space and key space is Z26. That is your alphabets E, B, C, D up to Z. So for first let us choose any key K. For any K belongs to K, belongs to the key space, and X belongs to P, the plain text space. How do we encrypt? Encryption is given by ek of x is equal to x plus p, sorry, x plus k modulo 26, and decryption is given by dk of x. It is just your encrypted value. This value is called y, we call it as y. So what we are going to do, y minus k modulo 26. Okay, this is a decryption. You will get back your plain text x. So what we are doing actually, we are shifting the position. For example, if you take k equal to 3, this k equal to 3, this is called Caesar cipher. If you take k equal to 3, this is Caesar cipher. It was introduced in late 100 to 44 BC. It was introduced by Julius Caesar. So what he told, you replace the alphabets by 3 places. That means I'm having A, B, C, D. Oh, sorry, let me just write small characters because so A, B, C, D, X, Y, Z. So the position, the number, it has 0, 0, it has 0, 1, it has 0, 2, and like this is 25, this is 24, this is 23. What he said, your key is 3 here. In Caesar cipher, if you encrypt it, the cipher text is going to be, this guy is going to be 3, this guy is going to be 4, this guy is going to be 5, like this guy is going to be 26, which is modulo 26. If you take it, this is going to be 0, then this is 27, this is 1, write 0, 0, 0, 1, 0, 2. So but what is this 0, 3? 0, 3 is your D. So this A is replaced by D, this is E, F, and 0, 0, that means it is replaced by A, B, and C. So in your, suppose I am having hello or hi, I am king. If let me just include this in, hi, I am king. So what you are going to do, you are going to replace this H by the table. You are saying I by the table, I am king, like the table, you have to just replace it. This is the encryption what you will be having. So if you see D, E, F, G, H, like this. So this is D is 3, 4, 5, 6, 7. So your value of H is 7, but if you encrypt it, you have to add 3. So 7 plus 3, the new value. First assign the values. First write the values, then add 3 in each of the character. See, like this. So it will be encrypted. And then look at the table. Here I have taken the example for k equal to 3. You can take another key for that. But here the problem is that the order of key space is 26. That means if somebody want to break it, they just have to try with this 26 characters. He'll start with k equal to 1 and check whether you are getting any meaningful message or not. He will do k equal to 2 and so on. He'll go up to k equal to 26, and that is easy for him. It has just 26 characters, so he can easily track. So this is not secure, but this was the oldest cipher which we have. So due to small key size, it is not secure. Due to small key size, it is not secure. Okay. And one thing you need to observe, that each character is replaced by unique character. This A is replaced by D, and in the later on this always whenever in the plain text you are having A, it will be always replaced by D. So each character is replaced by unique character. So this is the example of your mono alphabetic cipher, which I had already told in the beginning. Okay, so let us see the second one. I'll put P, which is affine cipher. Again, in the case of affine cipher, your plain text and cipher text space is Z26, but your key space is something else here. So what is the key space? Key space is set of all A comma B belonging to this Z26 cross Z26, satisfying GCD of A comma 26 should be 1. Why do we need GCD of A comma 26? One, we will be seeing it later on. Okay, so here your key is a tuple of two variable. It is having A and B. So let us see encryption for any key k equal to say A comma B and yeah, which belongs to your key space. And let us take a plain text X, which is in the P. How does the encryption define? Encryption is given by, what is the notation? EK of X. It is given by AX plus B modulo 26. Okay, so what I am doing, actually I am having two variable in the key K, that is A and B. So I am multiplying my plain text with the first variable A and then adding with B. This is what I am having. Whereas in the case of Caesar cipher, this A was 1 actually. I was just adding with key B, this X plus B. It was there in the case of shift cipher. But whereas in the case of affine cipher, I am having this. Now why do I need this GCD of A comma 26 is 1? If my GCD of A comma 26 is 1, then I can find the inverse. I can find A inverse. That this implies that A inverse exists. So if A inverse exists, how will you decrypt it? Decryption is easy. What you have to do, yeah, whatever the cipher text I'm having, this is my cipher text. I'll first subtract this B part, so I'll be having Y minus B. So if you subtract Y minus B, what you are remaining? You are remaining with AX. So I have to multiply with the inverse. So I'll multiply A inverse modulo 26. That means what I have to do, I have to first find A inverse, and whatever cipher text I am getting Y, I'll subtract with B and then multiply with A inverse. Whatever I'll be getting, that is my plain text. The correctness is easy, you can easily check. So this is how your affine cipher is. Now if you observe that, what is the key size here? In this case, your key size is actually yeah, A can have 5 of 26 and B can have 26. So this is my new key size. Earlier it was only 26, now it is 5 of 26 into 26, which is actually larger one. But still here also this will be actually 312. So again exhaustive key search, that is called brute force attack, is possible. Exhaustive key search, which is also called brute force attack. Brute force attack means what? We are going to check one by one all the possible value of k from 0 to 312, and then that is again easy because 312 is not a big number in nowadays. And it depends on your plain text space. I have taken Z26. If you had taken Z60, then it would be more than that 312. But still, it depends on your plain text space. Okay. Next is the substitution cipher. So what happens in substitution cipher actually? Your plain text, cipher text, and yeah, they are Z26. Okay, and your key space is S26. What is S26? That means it is the all the, yeah, it is actually permutation, set of all permutation, set of all permutations, say pi from Z26 to Z26. This is what your key space here. So how do you encrypt? Let us see the encryption. So here pi, let me take pi, which belongs to the key space. X is my plain text. Okay, and how do you encrypt? Encryption is easy. What you are going to do, e of pi is my key, so I'm going to write e of pi of x. This is equal to pi of x. Decryption, whatever I am getting this ciphertext, I just have to take the inverse. E pi of x is pi inverse of x. Since it is bijective, all the maps are bijective, this is bijective, so I can get the inverse of it, and that is easy. So this is what substitution. So in short, what is happening here, let me just tell you. See, this key, this pi is what, let us take, suppose pi is having 1 2 3 4. This is what it is having. That means what, 1 goes to 1, sorry, 1 goes to 2. I'll write 1 2 3 4, and other variable is fixed. So 1 goes to 2, 2 goes to 3, 3 goes to 4, and 4 goes to 1. This is what permutation I'm having. This is what pi I'm having, correct? So what it is having, everywhere in the plain text 1 is there, it will be replaced by 2. I am just substituting with this. Or simply you can check that all the time, what it you are given a table for every plain text character A, B, C, D. I am having some assigned value. It depends on your permutation. So let us say C, D, K, L, something like this. This is what I am having, a table, correct? So that's why it is called substitution cipher, because I am substituting the value with something else. Every variable I am substituting with something else. So what is the key space here? If you see, it is 26 factorial. So the key space, which is very large, oh sorry, 26 factorial, which is approximately, if you say that this is 10 raised to 26, which is very large. So at least the brute force attack is quite difficult here. It's not possible on this cipher text, but there are some other attacks which can be done on this. We'll be seeing later. So this is what substitution cipher is. Next is Vigenere cipher. Vigenere cipher. So in this case, your plain text, ciphertext, and key spaces say Z26 raised to M. That means it is M bit element. The plain text will be a M bit having each input as yeah, it is actually maybe you say M alphabets it has. Okay, so suppose I'm having, yeah, let us just give me the encryption and decryption rule. So what is the key here? K equal to, it has M elements, K1, K2 to Km. This is what your key belongs to, key space, and your plain text here X is X1, X2 to Xm. What I'm going to do, I'm going to encrypt. Encryption is like this. EK of X1, X2 up to Xm. You just add the key in each of the coordinate. Say X1 is added to K1, X2 is added to K2, and so on. So Xm is added to Km modulo 26. So whatever you are getting, that ciphertext, so let me write it as Y1, Y2 to Ym. This is your ciphertext which we call Y. Okay, how does the decryption happens? Decryption is easy. You just have to take decay of your ciphertext Y1, Y2, Ym. You have to subtract. It is actually similar to your shift cipher, but here we are taking M tuple together because my key space is again M tuple. So I am just taking Y1 minus K1, Y2 minus K2, and Ym minus Km. Whatever you will be getting, the modulo 26, you'll be getting your plain text, that is X1 to Xm, which is your X. So this is very simple. A simple example you can take here. What is happening actually? You have to divide it, divide your plain text into block. Suppose I have the message, hello world, I am a king here. So suppose this is the message what I am having. What you have to do, and suppose key space or key is given as a 4-bit number, say crypto, or let me say cry, let me put it as a key. So key is 3-bit element, correct? So it can encrypt only 3-bit number. So what you have to do, you have to divide your message into three blocks. So first write it as a number. So write the alphabet as I told you, A, B, C up to Z. Put A 00, put B as 01 up to 25. So like that, write the numbers. You'll be writing the numbers, and divide the blocks by 3. You divide the first 3, then next 3, and like this last 3. And what is the key? Key is cry. So I am going to write the numbers for the cry. That is, again I am going to encrypt it. I'll be getting number, not encrypt, I am going to write, by following this I'm going to write the values, and I'm going to put it here, add it with this guy, the same thing, add it with this guy, and so on. That means what is happening actually, in the case of shift cipher, I was having one element I was adding with this, but now I'm having a block of length 3. Since my key is of block length 3, so I am dividing my plain text into block length 3, and then adding with the key space, I'll be getting my ciphertext. So this will give me a ciphertext, this will give me a ciphertext. So altogether I'll be having this is my ciphertext, correct? But now the question, there should be a question: what if the final value, the last value is not in the block, or I am having only one people left here? So what will happen? In that case, we can use padding. You can use any variable, say z by filling, so that to make it as a suppose last element is only one, so I'll put z as the, to make it a block of size 3, I'll put zz. So you can, or any variable you can put, just you have to get to know about this. This should be known to you, that whatever you have entered here. So that is like a nonce which we are adding. Yeah, so this is called Vigenere cipher. Yeah, so in Vigenere cipher, we encrypt or decrypt a collection of M alphabetic plain text or ciphertext using a string of M alphabetic key. See, the size of the key space and plain text are same. If you observe, look at this. It was M bit, M length. This is also M length. Next is Hill cipher. Yeah, so what happens in Hill cipher? Again, your plain text and cipher text is this z26 raised to m. That means I am going to have a tuple of m element. This is my plain text and cipher text, and here your key is what? Key is all m cross m invertible matrices. All m cross m invertible matrices. This is what my tuple is in Z26. This is what my key space is. Okay, so how are we going to encrypt? That is the main question. So let me take a matrix, say M belongs to K, such that determinant of M is non-zero. So it is invertible, implies M inverse exists. Encryption is easy. How do you encrypt? Suppose I am having a plain text, say ek. Yeah, here also the plain text is a tuple, so x1 x2 up to xm. This is my plain text. So I'm having ek of x1 x2 up to xm. How do you encrypt? You just multiply this with the matrix m. x1 x2 xm, you're multiplying with the matrix m. That means this guy is multiplied with the matrix. You'll be getting a ciphertext, which we call it as y1 y2 ym, which is my ciphertext y. So what we are doing, actually we are just multiplying the plain text with a matrix. So this matrix is my key here, correct? So if you observe here, key space is very large because it has the set of all m cross m matrix invertible matrices, correct? So you cannot apply brute force to attack on it. How will you decrypt? Decryption is easy. As I told you that I have chosen a matrix M whose inverse exists. So for encryption I have just multiplied my plain text with M. So for decryption I have to just multiply the cipher, multiply the inverse of this. So in the case of decryption, I'm going to write dk. I should have written here my key is m, so I'll write dm. So it is dm of y1 y2 ym. It is equal to, just write y1 y2 ym. You multiply with m inverse. That means you already are doing y1 y2 ym. you are multiplying with the matrix inverse, you will be getting the plain text case, that plain text x1 x2 up to xm. This is what your plain text. So this is the Hill cipher, where the key is matrix. If you observe one thing, in all the crypto system discussed above, the character of the plain text is substituted by another character. Hence they are called substitution cipher. I'll just change the color. In all the crypto systems, discussed above, a character of a plain text is substituted by another character. It may not belong to the same. Okay, that's why it is called substitution cipher. So in the next class, we'll be dealing with we'll describe some crypto system where the characters of the plain text are not substituted by another character but permuted inside the plain text. That means whatever my plain text is, I'm going to permute it inside it. That will be the transposition cipher. Okay, thank you so much.